In this video, we're going to continue discussing inverses. Now, I left off in the last video talking about that the graphs of the original function and its inverse are symmetrical across the identity function, which is f of x equal to x. So now, two functions are going to be inverses of each other if and only if the composition of both functions in both directions ends up being x. Now, I can also rewrite that in terms of inverse notation. Okay. All right, so determine if f and g are inverses of each other. Well, again, I'm going to check to see if the composition going in both directions ends up being equal to x. So let's do on the side here, let's do the composition fg of x. Now remember, that is fg of x, and g of x in this case is 2x minus 3. So I'm going to go to the f function then and plug that in. So let's do that here. So in blue, I will rewrite it as 2x minus 3 plus 3, all divided by 2. So negative 3 plus 3 is 0, so that's 2x over 2, and that's equal to x. Now, again, that's only one direction. So now I'm going to do the composition gf of x, which again, I can rewrite as gf of x, and that's going to be x plus 3 divided by 2. So what am I going to do? I'm going to go into the g function now. So what? That's 2 times, and then I'm going to substitute in for x plus 3 over 2 minus 3. Okay, so the 2's to divide out, so that's x plus 3 minus 3, and 3 minus 3 is 0, so that leaves you with x. Okay, so f and g are inverses, since the composition fg of x and the composition gf of x both equal x. Okay. Now again, if either part did not equal x, then we know they're not inverses of each other. So this is nice to check to see if they're inverses, but I want to be able to determine the inverse of a function equation. So there's some steps that we would like to do for this. Number one, we want to verify the function is one-to-one. Replace function notation with y. We're going to interchange the domain and the range because that's what the inverse does. Solve the equation for y in terms of x, and then replace y with the inverse function notation. All right, so what I would like to do for each of these is to determine the inverse of each function, then write the domain and range of the inverse in interval notation. All right, let's start with the domain and range of f. Okay. Because this is a linear function that is not horizontal, we know the domain, negative infinity to positive infinity, and the range is exactly the same. Now, this is a one-to-one function because, again, it is a linear function. Okay, so this is one-to-one. Okay, now I'm going to replace the function notation with y. Okay. I'm going to interchange the domain and the range. And notice I'm going to solve this equation for y. So subtract the 4 and divide by 5. So again, notice it's still a line. Okay, I'm going to replace the y with inverse function notation. So that's what? This. Okay. Now, I want to determine the domain and the range of the inverse. Well, domain of this should be the same as the range of the original function. Okay. Well, again, there's no domain restrictions. There's no Range restrictions in the original, that's negative infinity to positive infinity. Okay. Range. Okay. The range of the inverse is the same thing as the domain of the original. Again, because it's a line, there's no range restrictions. There were no domain restrictions in the original. So the range of the inverse is also negative infinity to positive infinity. Now again, you can check the composition going in both directions for this to verify their inverses, but I will not do that in these videos. Okay, now let's talk about a square root function. Now, the domain is going to have restrictions because the index is even, or 2 in this case. So what do? I'm going to have to set the square root of x plus 1 greater than or equal to 0. Okay, square both sides. X is greater than or equal to negative 1. So the domain of g of x is negative 1 to infinity. Okay. Now the range, think about this. If I plug in negative 1, what do I have? Negative 1 plus 1 is 0. The square root of 0 is 0. That's the smallest value I can put in, and this is increasing. So we know the range is going to be 0 to infinity. Of course, 0 is included. All right, now, this is a one-to-one function because it is a square root function. I can easily graph this on the side. Okay, I'm going to go what? To the left 1. Okay, that is a one-to-one function. Okay. Now, what am I going to do? I'm going to replace the function notation with y. I'm going to interchange the domain and the range. Okay. And solve for y. So I'm going to square both sides. I'm going to scroll down a little. And then subtract 1. Now again, I want to rewrite this in inverse function notation. Okay. Now, let's talk about the domain of the inverse. Should be the same as the range of the original. Well, that's a good thing we wrote out the range, right? Because notice the range of the original is 0 to infinity. If I looked at just this x squared minus 1, I would have thought the domain is all real numbers. That is not the case because you had restrictions earlier. So this is also going to be 0 to infinity. The range is exactly the same as the domain of the original. Now, this is easy to figure out. Again, when I plug in 0, I get negative 1. That's the smallest value I have plugging in my domain for the inverse. So it should be greater than or equal to negative 1. Well, if you notice, the domain is exactly the same. So that should be negative 1 to infinity. Okay. This is exactly why for all of these I will write out the domain and the range of the original functions. That will help us to determine what the domain and the range of the inverse is going to be. Okay, so let's do the next example then. Again, this is a rational function. Okay. So let's start off with doing what the domain is. Now remember, there are domain restrictions in the denominator, so we can tell very quickly that x cannot equal negative 2, but I'll show this step here. So set the bottom equal to 0 and solve. Okay. So in interval notation, that's negative infinity to negative 2 or negative 2 to infinity. Now, the range. Now, a little bit more involved, and we have not talked a lot about this. So what I'm going to do is I'm going to use Desmos.com. Okay. And I have graphed f of x is equal to x plus 7 divided by x plus 2. Now again, you can tell very quickly with a domain restriction of negative 2 because it looks like they're going up and down vertically. We'll talk later on. This is what is called a vertical asymptote. Now, but let's take a look at the y values or the range. If you notice from the left-hand side, I'm getting very, 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 very close to 1, but I'm not ever going to be 1. Okay? If you go to the other side here, it's exactly the same thing. It gets really, really, really close to y equal to 1, but it's never y equal to 1. These are what are referred to as horizontal asymptotes. And again, we'll have more of a discussion with this later on. But more importantly, it looks to me like the range, okay, is going to be all real numbers except positive 1. Okay? So that's going to be what my range is going to be. And again, we'll have more of a discussion with this later on in the course. Okay, we know a rational function is 1-to-1. We've already shown that in the last video. So what I would like to do is to replace the function notation with y. Okay. Interchange the domain and the range. Keep in mind there are two y values. Multiply both sides by the denominator. And I'm going to distribute the x. Now, I'm going to bring all of my y terms to the left. So I'm going to subtract the y. And I'm going to bring the 2x over to the right-hand side. So I'm going to subtract 2x from both sides. So plus. Now, on the left-hand side, I'm going to factor out a y. That leaves me with x minus 1. Remember, y divided by y is 1, not 0. And now I can divide both sides by x minus 1. And I'm going to replace that y with inverse function notation. So I'll put that here. Okay, so let's talk about then the domain of the inverse. Remember, that's the same thing as the range of the original. Well, let's take a look at the domain of the inverse. We know x cannot equal 1, but it could equal any other value. Notice the range of h. We determined, thanks to Desmos, that it's all real numbers except 1. So they match. Now, the range. Okay, should be the same as the domain. So to help us determine the domain, let's go back to Desmos.com. So I have now graphed 7 minus 2x divided by x minus 1. So again, when we're taking a look at the range of the y values, it looks like from this side or this side that y is never going to equal negative 2. Okay? So now let's go back to the original problem. Okay? The domain of the original, it was all real numbers except negative 2, so it matches. So let's write. All right, so we have one other problem I want to take a look at then. Okay. All right, so this one is a quadratic function. So let's graph this very quickly. So x squared plus 2, it's a parabola that's moving up 2. Now, you can tell very quickly this is not a one-to-one function. Okay? You would fail the horizontal line test. Now, notice for us, though, it also says when x is greater than or equal to 0. So that means I really only care about what I'm shading in red. So if we only do what is shaded in red, now we have a one-to-one function. So now I want to write the domain. Well, they kind of already helped us with that, huh? Has to be greater than or equal to 0. So we know that's 0 to infinity. The range then, well, go back to the original picture. It starts at 2 and goes to positive infinity. Okay. And we've already checked. Now, the red shaded area, I'll put even that in red to remind you, the red shaded area is a one-to-one function. Okay, so now let's rewrite. Okay. Interchange the domain and the range. Okay. And solve this for y. So subtract the 2. And then take the square root. Now, we know then that should be plus or minus. But because of the fact that x is greater than or equal to 0, I only care about the positive answer for this. So all I care about is square root of x minus 2 is equal to y. Now, I'll make a note. If I said it originally that x is less than or equal to 0, which, by the way, if I shaded that, okay, we could tell very quickly that that's also a one-to-one function. Our answer would be negative square root of x minus 2. But because it's x is greater than or equal to 0 in the directions, I'm going to keep it as positive. Okay, write it, inverse function notation. Okay, now let's write the domain and the range for this. Okay, so the domain, again, we can tell very quickly it's got to be greater than or equal to 2. The range is exactly the same. It's greater than or equal to 2. They match. And the range should be the same as the domain of the original. Well, 2's smallest number in the domain, 2 minus 2 is 0. The square root of 0 is 0. So I should have non-negative values, or in other words, greater than or equal to 0. Well, the domain, as you can tell above, is exactly the same, so they match. I can write it from 0 to infinity, and I can include 0.